You've eaten fermented food today, probably several: bread, cheese, yogurt, pickles, soy sauce, coffee, chocolate, salami, beer, wine, vinegar, hot sauce, kimchi, sauerkraut, miso, tempeh. The list goes on. What you might not realize is that fermentation isn't just a cooking trick. It's the oldest biotechnology humans ever mastered, and for most of history, we had no idea how it actually worked. For thousands of years, people transformed milk into cheese, grain into beer, and cabbage into something that could survive a winter without refrigeration. They passed down recipes, rituals, and timing. But the mechanism? That remained invisible. No one knew what was actually happening inside those jars and barrels. They just knew it worked. And it worked so well that entire civilizations built themselves around it. The earliest evidence of fermentation goes back roughly 9,000 years. Archaeologists have found residue in pottery from Neolithic China that suggests people were brewing a fermented beverage from rice, honey, and fruit. Similar findings appear in the Middle East around the same time. Bread, beer, and wine show up in ancient Sumerian and Egyptian records. Fermentation predates writing itself. It predates the wheel. It may even predate agriculture, if you consider that the desire for a reliable supply of fermentable grain could have motivated people to settle down and farm in the first place. That possibility hasn't been settled, but it has been taken seriously by archaeologists for decades. So why did early humans bother? Fermentation solved three critical problems at once. First, preservation. Fresh food spoils fast. Fermented food can last months, even years. Second, safety. Fermentation creates an acidic environment that kills or outcompetes dangerous bacteria. In a world without clean water, fermented drinks were often safer than water itself. Third, nutrition. Fermentation can break down compounds that our bodies struggle to process, unlock vitamins, and even produce new nutrients that weren't present in the original ingredients. A fermented soybean is dramatically more digestible than a raw one. These weren't minor conveniences, they were survival advantages compounded over generations. But here's the paradox. For nearly all of human history, fermentation was controlled without being understood. People knew the steps, they knew the timing, they knew what success looked and smelled and tasted like, but they didn't know what was doing the work. Some cultures attributed it to spirits or divine intervention. Others simply treated it as a natural mystery, no different from the seasons or the tides. Recipes were guarded secrets, passed down orally, adjusted by instinct and experience. If your sourdough starter died, you borrowed some from a neighbor. If your beer went sour, you adjusted the process and tried again. Trial, error, tradition. The technology worked, but the science was invisible. The turning point came in the 1860s. Louis Pasteur, a French chemist, was hired by winemakers and brewers to figure out why their products kept spoiling. At the time, most scientists believed fermentation was a purely chemical process, a spontaneous breakdown of organic matter with no living agent involved. Pasteur suspected otherwise. He examined fermenting liquids under a microscope and identified living organisms, yeast and bacteria, actively consuming sugars and producing alcohol, acid, and gas as byproducts. He demonstrated that fermentation was biological. It required microbes. And if you controlled the microbes, you could control the outcome. That finding reframed everything that had come before it. This was a revolution in practice, not just in theory. Pasteur's work gave industry a new tool: predictability. Breweries could isolate specific yeast strains and reproduce the same flavor batch after batch. Dairies could pasteurize milk to eliminate unwanted bacteria before introducing the right ones for cheese or yogurt. Factories could scale up production because the process was no longer mysterious. It was microbial. It was manageable. Within a few decades, fermentation shifted from craft to industry. What had been a local, variable, artisan process became something you could engineer at scale. But industrialization introduced a trade-off that took generations to fully recognize. Traditional fermentation was slow, unpredictable, and regionally diverse. Every location had its own population of wild yeast and bacteria, shaped by local climate, ambient organisms, water chemistry, and practice. That's why bread made in San Francisco tasted different from bread made in Paris. Industrial fermentation prioritized consistency and speed above everything else. Companies selected a handful of high-performing microbial strains, optimized the conditions around them, and systematically eliminated variation. The result was reliable products, lower costs, and massive scale. Also, quietly, less diversity. Many traditional strains and regional techniques disappeared because they couldn't compete with industrial efficiency. The knowledge embedded in those strains often disappeared with them. Take soy sauce as a concrete example. Traditional fermentation takes months or even years, relying on naturally occurring mold, yeast, and bacteria, working through a slow, layered biological process. The flavor that results reflects that time and complexity. Modern industrial soy sauce often uses a method called acid hydrolysis, which bypasses fermentation entirely by breaking down soybeans with hydrochloric acid in a matter of hours. It's faster, it's cheaper, and it produces a recognizable result. But the flavor profile is measurably different. Some producers use a hybrid approach, blending fermented and hydrolyzed soy sauce to balance cost and taste. The label frequently won't tell you which method was used or in what proportion. Or consider bread. For most of human history, bread was leavened with wild yeast drawn from the surrounding air or maintained in a sourdough starter passed down over years. In the late 1800s, commercial yeast became widely available. It was faster, more predictable, and required no maintenance. Within a generation, sourdough starters became rare in much of the world. Today, most commercial bread is made with a single yeast species, Saccharomyces cerevisiae, cultivated in industrial facilities and sold in uniform packets. It works efficiently and consistently, but it represents a dramatically narrower slice of the microbial diversity that fermentation once drew on. And yet that diversity hasn't vanished entirely. In the past 2 decades, there's been a measurable resurgence of interest in traditional fermentation methods. Small-scale producers are reviving old techniques, often deliberately. Home fermenters are experimenting with wild cultures. Scientists are cataloging heirloom microbial strains and studying their distinct properties. Some of these strains produce flavor compounds or nutritional profiles that industrial monocultures don't replicate. Some are more resilient to environmental variation in ways that could matter as climate conditions shift. The central question now is whether this renewed interest can coexist sustainably with industrial scale, or whether fermentation will continue dividing into 2 separate tracks: craft on one side, commodity on the other. There's a broader lesson running underneath all of this. Fermentation is a reminder that humans have been manipulating biology for thousands of years, long before we understood what we were doing or had the vocabulary to describe it. We domesticated microbes the same way we domesticated plants and animals, by selecting for useful traits over time, even when we couldn't see the organisms themselves. The Industrial Revolution didn't invent biotechnology. It made existing biotechnology visible, measurable, and scalable. The microbes were always there, working in the dark, transforming raw ingredients into something more stable, more nutritious, and more complex. So the next time you eat bread, drink beer, or open a jar of pickles, you're consuming the result of a biological partnership that predates civilization. A partnership humans stumbled into, perfected through instinct and accident, then industrialized for efficiency, and are only now beginning to map with any scientific precision. Fermentation didn't originate in a laboratory. It originated in a clay pot, thousands of years ago, with someone who noticed that leaving certain foods alone sometimes made them better. That accidental observation became the foundation of half the food supply on Earth. The organisms responsible are still there. The question we're still working out is how much of that original diversity we can afford to keep. Visual reconstructions are illustrative. Facts and interpretations are based on the sources listed in the description.